Hello and welcome back. Today we're going to look at some application style problems which involve properties of exponents which you have in your foldable. So you're going to want to have that with you so you can easily reference what I'm going through and how I'm going through each one of these simplification processes. Okay? So the first thing we'll look at here is which property is at work. I'm going to go ahead and look right at the zero power, because even though this is a very complicated problem, which I could simplify all of these exponents with, I am simply going to rewrite this as 1, because this 0 will be distributed or multiplied to every exponent within this entire problem, which means that the dominating effect here is the 0 property. For this one, I'm going to recall that the area of a triangle is base times height divided by 2. And now I'm going to plug in these numbers to that equation to simplify it. So I get a to the third times b times 2a to the third b to the sixth divided by 2. Now what I like to do is I like to go ahead and set up a fraction bar, and then I'll simplify the previous step and place the new simplified numbers in here as I simplify them. So I'm just going to go ahead and go from left to right. I'm going to start with a. There is another a here, and I'm going to use the product property because they are both in line with one another and being multiplied, so that means 3 plus 3 is 6. So that's a to the 6th power. Continuing on, I'm going to find my b's, and now I get 6 plus 1, which is 7, and that's b to the 7th power. Now I'm going to deal with my numbers, and 2 divided by 2 is 1, so my final result is that. Next, it's asking for the volume. So volume of a cylinder is the area of the base times its height. Volume, area of the base is pi r squared times h, and now I'm ready to fill in. Volume equals pi times the radius 5x to the 8th y to the 3rd squared times h, which is 3x to the negative 2 y. Alright, again, get into my habit, draw my fraction bar. Now I'm going to simplify this piece by piece. There is no pi, so I'm just going to go ahead and put it there. Okay, now what I'm going to do is I'm going to use this property of multiplication to get all those guys distributed throughout. So 5 squared is 25. This is multiplication, so that's x to the 16th power. That's y to the 6th. Now I'm going to go here. The 3 is just going to stay put for a second. And then this negative tells me that I'm going to remove this from the numerator and put it down at the bottom. And I'll keep it lined up here just to keep it easier for me in the next step. Again, the 0 property makes that 1, so it's not necessary to rewrite that. Okay. Again, the empty fraction bar, and now we'll simplify. 25 times 3 is 75, so that's 75 pi. 16 minus 2 is 14. There's more x's on top, so that's x to the 14th power. There are no y's to simplify, so it's y to the 6th, and that's my final answer. Down to the next set of problems. The volume of rectangular prism in terms of x with its length as that. Okay? Width as this, and height as this. The thing that we're going to start to really see a lot in the next several days is a perfect square trinomial. So I want to really point out that to you so you can know when to recognize it and know how to figure out what it simplifies to. So volume equals x minus 2 times x minus 2, but that's x minus 2 squared, times 6x plus 2. Now, as I'd said previously in the properties of exponents, we're going to get into a bad habit here if we're not careful of just multiplying this 2 to everything. But remember, this is one number that has two non-like terms, so that's why it looks this way. So we can't actually multiply the 2 to the 2 and the x, 2 to the x. I can't do that. So please make sure that you distinguish between this and what we did previously, which was this. This is multiplication. These are all individual numbers. This is a quantity called x minus 2. We cannot multiply to each one of these exponents because this is actually just one number. It just has two unlike terms, okay? So, perfect square trinomial, that's a squared plus or minus, whichever one we have. In this case, it's minus 2 times a times b plus b squared. Okay, perfect square trinomial. Put it back in your memory banks, dust all the cobwebs off. We're going to use that a lot. Okay, so that's going to be volume equals x squared minus 4x plus 4 times 6x plus 2. Now I've got to use that FOIL or distribution method, and I'm going to get this first, and so I get 6x to the third minus, plus 2x squared minus 24x minus 8x. Sorry, that's squared. Got to catch me on those. Plus 24x plus 8. Now I'm going to combine some more like terms. This one doesn't have any, so that's just 6x to the third. There's a 2 and a 24, which makes negative 22x squared. There's this one and this one, which makes positive 16x. And then that's going to be plus 8. Looks like there's a GCF in there, so if you were asked to take out the GCF, you could, but that's going to be what I'm looking at as far as a simplified form of this particular problem. Writing expression for the radius of a circle if the area is given. Okay, so that's pi r squared because it said area. Okay, plug that in, and I get 4 pi x to the 8th y squared equals pi r squared. Okay, so I'm going to divide out my pi. That makes it nice. Okay, and I get 4 x to the 8th y squared equals radius squared. Next thing I'm going to do is I'm going to bring back that property. When you have something squared, just square root it. And then I get r equals, the square root of 4 is 2. Okay. And then I'm going to simplify this radical. This is from before. And that's going to be x to the 4th. Remember, that's just divide that by 2. And then y. And there's your final answer. We're going to get more practice with simplifying radicals again in the upcoming days, so we're not going to spend a lot of time on that right now. I'd like you to do question number 6. YD, you do. And bring that back to me tomorrow with any questions that you might have so that we can take a look at that together. It should be pretty straightforward at this point with the examples that you have been given. All right. Now what we're going to do is we're going to address solving for x. And we're going to solve for x in a multitude of ways. So you're going to want to look at each one of these different variations so that you're able to recognize what's happening, okay? Much like before, I'm going to do a 1 and then you're going to do 1 and so on and so forth. So there will be some work involved, so please make sure that you're taking care of this as you're going along. All right, so first and foremost, you got to recognize the property which is being used here. That's the product property. The bases are the same, so that's going to be 2 to the x plus 7 power equals 2 to the 5th. Now this is the pattern. This is what you're going to want every exponential equation to look like in order for you to solve the exponents, okay? There's a property which states that if the bases of the exponents are the same, then the exponents themselves are equal to each other. Okay, and that's the property we're going to utilize here to help us simplify and solve these problems to get what x is. So take a look at the bases. They're the same. That means I can drop them out, and we're going to have x plus 7 equals 5. You can only do this after the bases are the same. You'll notice moving forward from here that there's going to be some issue, so we're going to have to take a very careful look at that. Okay? Subtract 7 to both sides, and I get x equals -2. That's how that works. All right, identify the property in number 8, and go ahead and solve that one for me. I will check that tomorrow at the beginning of class. Number 9, very complicated, but actually very simple. You've got to look at the properties that are being used here. The first property that is being used is the quotient property. So 6 minus 6 is 0, which means these cancel out. So we got 5 minus to the -2x power equals 5 to the 5th. So what was complicated is actually very simple. Are the bases the same? Yes, they are, so I can drop them out. And the exponents themselves are equal. And my final answer is going to be x equals -5/2. Okay, question number 10 is the first time that we're going to address a situation where the bases are different. So what we got to do here is we got to figure out a way to make the bases the same in order to solve the exponents properly. Now later on, when we get to the logarithms, you'll note that that doesn't always have to be the case, but for right now, we're going to do this. So get into the habit of understanding that if you have an exponential equation where the two bases are different from one another, that means one of the bases will change into the other one, or both of them will change into the same number. Okay? So in this particular case, we're looking to make the 32 somehow into a 2. I know that 2 to the 5th power equals 32. So now I can change that, and I get 2 to the 2x plus 1 power equals 2 to the 5th power. Bases are the same, drop them out. 2x plus 1 equals 5. Subtract 1 to both sides, and I get 2x equals 4. And divide both sides by 2, and x equals 2. So recognize that the bases can change to become the same thing, okay? You try number 11, see if you can get that figured out, all right? Okay, back up to question number 12. Back to 12, take a look at it here. What we're going to do is we're going to address the situation where both of these can change to the same number, because there isn't any number that 64 will turn into where its base will be 16. It's just not the case. So both of them have to be changed. And this is going to be a situation where you've got to really understand what your perfect squares, cubes, so on and so forth are. Okay? So this one is going to be 2 to the 4th power. Notice that there's already an exponent up there. So we're just going to go ahead and put it next to it as multiplication. That might help you back with number 11 if you got stuck on that a moment ago. All right? And on this one, 64 turns into 2 to the 6th. Now the bases are the same, and I get 4x plus 8, I just distributed that through, equals 6. Subtracting 8 to both sides gives me 4x equals -2. Divide by 4 gives me -1/2. So x equals -1/2 in this situation. All right, I'd like you to try number 13. It's kind of tricky, but use what I do in question number 14 to see if you can figure out what to do if you get stuck. All right, number 14. Notice I'm going to change the 8 into a 2. All right, but notice also that they are not in the same position in the fraction, which means that somehow, some way, I've got to get rid of this fraction. So that brings back that negative property that we've used before, because what I can do here is if I apply the negative property in reverse, that's going to move the 8 back to the top. But in moving the 8 back to the top, it's going to make the exponent of the 8 negative. All right? So I get 2 to the x plus 1 power. Now what I'm going to do this in 2 steps so that you can see clearly what I've done. In order to apply the negative property, that's 8 to the first power. So to move it again back to its old position at the top of the fraction, it's got to be 8 to the negative 1 power. See how I did that? I just moved it back by using the negative property in reverse. And then of course the 3x is there. Okay. Now that we've done that, now I'm going to address the 8 and the 2. Well, that's 2 to the third power, so it's going to be 2x plus 1 equals 2 to the negative third power times 3x. Now, of course, you can do that in one step. No big deal. But I just wanted to show you those 2 steps separately so you understood how the negative property worked, and specifically. Bases are the same. Drop them out. X plus 1 equals negative 9x. Subtract your, add your 9's to the other side. Give me 9x over here. And subtract your 1. So that's going to be 10x equals negative 1. Divide both sides by 10. And I get x equals negative 1 over 10. All right, before we move on, I want to help you visualize what's going on here so you can see clearly how it is that we're getting these answers. We're moving into a very abstract portion of the learning, and I want to, as much as possible, give you tools and analysis that you can use to help you visualize what's going on. So we're going to go back to question number 10, and we're going to readdress question number 14. What I'm going to do is I'm going to let you guys use Desmos in the upcoming days a little bit more than we have in the past, because I want you to be able to visualize what's going on. So in question number 10, we had the horizontal line 32. That's what I put into, let me open this up so I show you what you see. That's what I put into y1 or y2 of my calculator. In this case, it's Desmos, okay? So that's one side of the equation. Notice the other side of the equation is going to be the other. And now you can see clearly that you have an exponential curve and a horizontal line, and they intersect each other at the value of 2. So I'm helping you visualize the mathematics because it is rather abstract and it's hard for you to tell how I'm getting these answers, okay? So that's one way to do it. And question number 14, you can see here that you've got 2 exponential curves. One is decay, the other one is growth, and there they are. One side of the equation, the other side of the equation, y1, y2 if you're using your calculator for future reference. And then of course this intersection point is negative 1/10. And you can see that by the value of x, because that's the missing value in this particular problem. So hopefully that will help you visualize what it is that I'm asking you to do when you're asked to solve these problems, okay? All right, question number 15 is a you-do assignment, so please be ready to solve that problem or have that problem solved when you come to class tomorrow so that we can talk about it, discuss it. You can go collaborate with your group mates and get that done, okay? Thank you very much.